Good evening, my YouTube viewers. Crystal here. What I wanted to do tonight was I wanted to go over with you the solution to the Titanic competition with Kaggle. And what I did was I used an ensemble of models, and I wanted to go over that ensemble with you. Basically, what happens is people use an ensemble of models because they're hoping that if they use the three models that they will get a better overall accuracy of their prediction than they would have if they only used one model individually. So I did this model today, the ensemble of the three models today, and then I submitted it to Kaggle, and I got a 78.468%, which I believe it to be the highest that I've done. But when I went onto the leaderboard, they said no, that it's not my highest score. But I don't see it as being the lowest score. It's certainly a good score. I can go over with you my predictions. And so, like with Titanic Keras, I only did a 77.99%. And then I had to keep working on the Keras to get the score up, because you can see that the score wasn't up before that. And then when I used the decision tree, I only had 75.119%. And it keeps going on. I was experimenting with various weightings and mechanisms within the coding, and you can see I wasn't doing a very good job because my accuracy was going down pretty low. And so I did the XGB classifier, which was 74.880%, and I believe that was my highest percentile that I've made. But as you can see, I experiment with the weightings and the timings and the sample rates and things like that to try to get the score as high as possible. And when I got my 78.468%, I decided to leave it at that, and I didn't even experiment with the size of the training set, because they say that if you want your data to be, your prediction to be more accurate, you need to get more data. Well, I couldn't get more data, but I could increase the size of my training set and decrease the size of my testing set to give me more data to train on. So now that I showed you my score, then what I'll do is I'll go ahead and go into my notebooks, and I'll go into Titanic Ensemble, which is what I was working on to get my score up to 78.468, which I think was okay, even though it was not as high as the XG Boost. So I want to go over this with you, but before I do, what I'm going to do is I'm going to make my notebook public. So if you wanted to look at the notebook and go along with me, you're able to do that. So the first thing I did was I imported lots of directories. I'm sure I imported more than what I needed to import, but there you go. And then the second thing I did was I imported the file. So we had the test file, the train file, and the gender submission file. And the next thing I did was I read the files. I read the train file and the test file. And so you can see the train file. It's got lots of digits in it, lots of data in it. You can see the train info. You can see we've got quite a few objects. You can see the description of the train file. And you can see the test file in exactly the same format. The only difference between the test file and the train file is the test file does not have a survived column. And then I put some coding in there to see if there were any null values. And yes, we found out that there were null values in the train file and the test file. And so the next thing I did was I put some coding in the program to replace all of the null values with mode, except for the age. Any place where there wasn't an age, it was replaced with median. And then I looked, to see if there were any more null characters. And no, there were no more null characters, so we can proceed. So now you can see the train file with no null characters and the test file with no null characters. So the first thing we wanted to do is we wanted to take the title out of the name, and we created a new column called title. And these were all the titles, except for some reason there was another title called Donna, but the software didn't pick it up. But I picked it up when I was going through the names, and I found out that Donna was a title that it didn't pick up, so I included it in the mapping. So here you can see here that instead of having a title, we just have a number. So what we wanted to do is we wanted to check to see if there were null characters in title, and no, there were not any null characters in title. We did the same thing with the passenger class. There were 3 classes, first, second, and third. So we did a group by of the passenger class to see how many people were in the passenger class. The next thing we did was we checked to see if there were any null values, and no, there were not any null values. We did the same thing with the sex. We grouped the sex together, and you can see they had 2 sexes, male and female. The male and female were assigned numbers, and then after we mapped. And after we assigned numbers and mapped them, we did another group by, so you could see how many males and how many females there were. We wanted to see if there were any null characters in the sex column, and no, there were not any null characters. The next thing we did was we grouped the age, and we wanted to see how many people of each age had survived. And we had a violin chart of the age, and these ages were grouped together and grouped together so we could make a chart. The next thing we did was we put the different ages in categories: child, young adult, middle-aged, and pensioner, and we put all of these ages in bins. So what we wanted to do was we wanted to see how many people of each category had survived. So we had to assign each age range to a number, because this is a logistic competition, and so we're dealing with numerical value. And the next thing we wanted to do is see if there were any null characters in the age range, and no, there were not any null characters. And what we did was we gave each category a number, and so you can see how each category got a number. Then we sorted the SIB spouse out with and called it family, and you can see how many people survived. So if the person was traveling on their own, they had a higher chance of survival than a person who had a family with him. And if a person was in a couple, they had the second highest chance of survival than if they had their family with them. So we made a violin chart, and you can see people traveling on their own who were single had a higher chance of survival than people who were traveling with people. In Parge, I think that's your parent-child. What we did was that was isolated into numbers as well. And you can see that, again, people traveling alone had a higher chance of survival than people who were traveling with people. And we've got a violin chart to show that people traveling on their own had a higher chance of survival than people who were traveling with people. The next thing we did was we checked the fairs, and you can see there were all these different fairs. So we did a violin chart, and you can see that there were more lower fares than there were higher fares. And we put these fares into categories of 0 to 99, 100 to 199, 200 to 299, 300 to 399, and 400 plus. And we put those in categories, and you can see that they were grouped by category. And you can see that the people with the lower fares had higher chance of survivals. So we had to assign the fare range a number because this is a numeric. The algorithms will only take numeric characters. And we checked to see if there were any null characters in fare range. And no, there were not any null characters. The next thing that we checked was embarked. And people embarked from 3 locations. And the people who embarked from Southampton, there were more survivors from Southampton than there were from the other locations. We assigned the 3 locations a number and mapped it into the column. And then what we did was we checked to see if embarked had any null characters, and embarked did not have any null characters. And so after we did all that, we did some more coding to see if there were any null characters in the train set and the test set. And no, there were not any null characters in the train set and the test set. So we tested 2 ways to check for null characters. So now you can see the train set after the data has been manipulated, and you can see the test set after the data has been manipulated. So we checked the train types. So you have 2 categories, an age range and a fare range, and then everything else is a digit or a number except for the cabin and the name and the ticket. And it's the same thing for the test file as well. So what we did was we did a heat map to see how the different variables correlate to the sale price. And the next thing we decided to do is we decided to drop the name, cabin, and ticket because those were objects, and it would be very difficult for the models to accept objects, so we just dropped them. We set our Y value as being the survived column, and our features as being the P class, sex, parched, embarked, titled, age range, SIB spouse, and fare range. We set our X value as PD get dummies, train features, and X test as PD get dummies, test features. You can see what X looks like, and you can see all the 0s and 1s, and you can see what X test looks like. The next thing we did was we imported our simple imputer, and we set up our values, and we imputed those values, and we transformed them. The next thing we did was we put the values into the min-max scaler to set up a range of between 0 and 1. So now all of the values in the data set are between 0 and 1. And we normalized the data and put it in a fit scaler. The next thing we did was we did a test train split with the X train, X validation, Y train, Y validation. So we split the data into 2 parts, the training file and the testing file. The training file was 80% and the testing file was 20%. And I suppose if I had wanted to increase my accuracy, I could have made the training file 90% and the testing file 10%, but I didn't do that. I was so pleased to have the accuracy that I had that I just let it go. But I was reading some literature, and it said that you the way that you improve your accuracy is to get more data. And the only way I can get more data is to increase my training file and decrease my testing file. So now what we did was we set up our K-fold and our decision tree classifier. So that was one of our models. And then we used a bagging classifier because bagging classifiers are used in ensembles. And then so we have our results equals model selection dot cross validation val score XY CV and then we print the results, gave you an accuracy of 81.4856%. The next thing we did was we did ADA Boost, which is another model. And so that's our second model. And then we checked the results, and that's 81.598%. And the last model we used was a logistic regression model. And then what we did was model 1 was a logistic regression, model 2 was decision tree classifier, and model 3 was SVC. So you had 3 models that were used. And so the results were model selection dot cross val score Ensemble XYCV, and you printed the results to give you an 80.248439%. So I wanted to see what was in the Ensemble. So the Ensemble was the logistic regression, the decision tree classifier, and the SVC. So the Ensemble had those 3 models in it, and it was going to, the theory is if you've got 3 different models, those 3 models are going to give you a better prediction than if you had used one model on its own. So then the next thing we did was we fit the ensemble. So ensemble.fit X train Y train. And then the next thing we did was we predicted the ensemble. So ypred equals ensemble.predict X test. Submission equals PD data frame, passenger survivor ID, which was the test passenger ID, and then the survived was ypred. And then we converted that to a CSV file, and here you can see the submission file. And the submission file is what we submitted to Kaggle to give us the accuracy. And I was just so surprised that it worked because I had gotten the algorithms from a website that was talking about ensembles, but I had to figure out how to put the algorithms into the Kaggle competition in the form that Kaggle wanted it to be submitted. So I had to figure that out on my own. And so I had to fit it because it wasn't fit. You can see that it wasn't fit. So I had to fit it, and then I had to predict it. And so I did have to use a little bit of my skills to put 3 algorithms together to form one. And I wanted to show that to you, and just so you can see it and you can use it if you want to. I mean, obviously it's not the highest score, but it will get you on the leaderboard, and it will teach you a little bit about ensembles as well, which is why I've made my notebook public. So that concludes my video for today. If you like my video, please like, subscribe, and share. If you want to support the work I'm doing, I've got my email address down below in the comment section with my PayPal account for donations, because I don't have enough subscribers, and the only way I can make money on my videos is to ask donations. So thank you so much for watching my video, and I look forward to making the next one for you.